Your time has started, Team G. Grace, sorry, Kosi.
Okay, please confirm you can see my screen.
Yeah, it is visible.
Okay, thank you very much. So I'm going to go over again. So good evening, everybody. My name is Enekosi. Which is talking about how we were able to migrate to build a scalable e-commerce platform on AWS. So for this project, we were able to for this project, um, I'll just talk about what the project is about, and then I'll go into what we were able to solve and how we were able to solve it. That means showing you the step by step process we took to actualize this project. So PayCart is a cloud native e-commerce platform built entirely on AWS. So it was designed and implemented as a response to the challenges faced by the PayCart startup on shared hosting infrastructure. So the platform was migrated to AWS to deliver high availability, automatic scalability, enterprise grade security, and real time monitoring. So these are the things that our project was able to solve. So we're able to integrate everything on AWS, and um, you're able to integrate the platform on AWS and make sure that it's fully functional, and then it's able to like meet all the business requirements that it's supposed to meet. So these are the business requirements. If you can see my screen, you can see the business requirements here and our solution to that. So we have high availability and fault tolerance. So our solution to that was we were able to use CloudFront, which is a content delivery network um, and service on AWS, and also we used Lambda, which was able to provide multiple availability zone by default. And we also used S3 buckets, which we used to host our front end, which we used to host our front end. So and we replicated in three availability zones. So this was our solution to meet this requirement, this business requirement. So that we also met the requirements of like handling large traffic spike. So we used AWS Lambda to scale concurrently automatically. So we Lambda was what the service that we used to be able to solve the problem of large traffic spike, which we are going to be explaining along the line. So we're able to enable continuous deployment. Once we run the build command on our end, it automatically uploads to the S3 bucket, and then the CloudFront invalidation, and then everything updates. So also going to be talking about that as well. So for security, we implemented the principle of least privilege by integrating IAM rules for each services, integrating HTTPS, because when we uploaded to CloudFront, because we used Cloudflare for our security, we didn't use AWS WAF from our previous proposal because of cost. So we're trying to optimize cost. So we use Cloudflare, which is a free platform um, for that. So we use Cloudflare, and we enabled HTTPS because on the normal it comes default with HTTP, so we had to enforce HTTPS for it. So our database has RLS, so we also integrated DDoS protection and CloudFront. So for monitoring and logging, we use CloudWatch data dashboard, SNS alerts, which um, we integrated so that every one of us are able to receive alerts if there's any traffic spike or anything. We integrated that as well. Our cloud watch was able to show Lambda logs and API gateway metrics. So cost optimization for as well. We're able to solve that problem as well. So we worked on services we worked on a fully serverless architecture. So we're able to minimize cost. And then our fully documented architecture. So here we have our architectural design, which has all the services that we used for the project. So we used Route 53 for DNS routing. So we used it because it is an AWS native DNS service that is 100% SLA and integrates natively with CloudFront via alias records. So it's AWS. It is an AWS service and it is very much reliable. So we used it, although it has its cost attached to it, but that's what we use for our project. So then we also use ACM for the certificate ACM, that is certificate manager, for our SSL and TLS certificate for HTTPS. So we use CloudFront for our CDM content delivery service and for DDoS protection. So our S3 bucket was used for our static front end hosting. Then we used API gateway to manage our API. We use Lambda for our to host our backend. So that was what we used to host our backend, which someone from my team is going to be talking about as well. So we used IAM for access control because we were able to create users for each one of us as we worked on the project. So IAM was used to control to manage the access and also assign roles and privileges to each person. So we also use CloudWatch for monitoring, alerts, and logging. So we use Superbase, which is an external database, because we are trying to optimize costs. We're trying to optimize costs. So we didn't use the ideal database, AWS database. So we use Superbase, which is 100% free. So we used it to manage our PostgreSQL authentication. Sorry. All right. Okay. So this is our architecture. This is the architecture for our project. So here the user is going to send a request which goes through Route 53 for DNS, and then it goes from there. It goes to the cloud front, which works for content delivery network and all that. So from there, from the cloud front, we're able to fetch our static website, which is hosted on the S3. From there, it was able to fetch our static website, which is hosted on the on S3. So we used the API gateway, and we used Lambda to host our backend, and then we used API gateway to be able to connect it with our front end service, and then we use CloudWatch for monitoring as well. So I'm going to hand over to the next person who is going to talk about how we were able to implement our backend, and also talk about how we were able to set up the database and the backend. Okay, sorry, I think Great is not on the call, so I'm going to hand over to the person that is going to talk about the front end. The person that is supposed to talk about our back end is not on the call with us, so we're going to talk about the front end and how we're able to integrate that as well. So, Sito, please, can you help us speak about the front end?
Good evening, everyone. Please confirm you can hear me. Hello.
We can hear you, Sito.
All right. Okay, my name is Sito, and I'll be walking through how we set up our front end. So we worked with three services, which is the AWS Certificate Manager, the S3, the CloudFront, and the Route 53. Okay, so before we started, we requested a public SSL certificate from AWS Manager, right? This is going to help us manage our SSL certificates so our users can securely communicate on our website. Now, at the bottom, you would see a disclaimer, right? That we weren't able to use any other region as US, right? So the certificate has to be specifically created from US East 1. If not, CloudFront would reject. Then the next one was to build our website, which we use React, right? Now for us to actually upload this React on this our website, that's the asset, a static, a HTML, we had to first run npm run build to build a directory that will enable us to host static assets on S3. So we did it on VS Code, and we had a build file, right? And we deployed it to our S3, and our configuration was included. We disabled. Sorry, could you go up? Okay, thank you very much. So we uploaded our build um, file onto our S3 bucket, right? And disabled block access public. We blocked public access. This is done so is not accessible from the internet. Only CloudFront will be able to access it, right? CloudFront will be able to access it. And we added a public policy, as you can see, attached to the screenshot. Could you scroll down? Hello, Kosi, can you hear me?
Yes, I can hear you.
Could you scroll down a bit?
Okay. Oh, down. Sorry.
Okay, so next, because before we actually deploy our CloudFront, we have to first actually create our S3 buckets. So after we created our S3 buckets, we set. Could you scroll down, please? Thank you very much. Okay, so these are the different the various configurations that were implemented in our CloudFront, where our origin was to be S3, where it takes the static assets, the static content, and then displays it for the user. So we set our origin as S3. Our origin protocol would be HTTP, right? HTTP, and we attached the certificate that we created earlier, and we also added alternate domain name, which is paycart.online and www.paycart. So CloudFront would handle um, um, the difficulty we had with shared hosting, which was delayed distribution, right? So it handled low latency, right? That is, our users will get the website within milliseconds. So that is what the CloudFront and the S3 was there for. And now for Route 53, which is going to act as our DNS and our routing service to efficiently route traffic to our AWS environment. So we created a public hosted zone for our website in Route 53, created records for root domain, created for a subdomain to route to cloud to the same CloudFront distribution, right? Updated our name servers at domain registrar to replace existing name servers with Route 53. So these are the different configurations we did on Route 53, CloudFront, S3, and AWS Certificate Manager. All this will work together to create our front end for our users. Thank you. Hand it to our back end engineer to speak.
Okay, sorry. I think Great is not on the call, but he was supposed to talk about how we were able to implement Lambda function and the API gateway as well. So like I said, I created the IAM role for the Lambda execution where when I was assigning roles. So I created the IAM role. So, but this part of the project was what he did. But basically, what he did was he built a Lambda function in Node.js and using Superbase JS client. So each function was packaged, and then he pushed it. Each function was packaged and um, changed into a zip file and then was deployed to AWS Lambda. So, and the environment variable for the each function and also the URL for the Superbase and the Superbase key was also attached to our and was set and also attached to our front end file, which was pushed to our S3 bucket. So we attached the Lambda execution rule, which was created to each function, and each function individually used the Lambda text test console. So we also created an a REST API in the API gateway, which is an endpoint, which was the endpoint we used for the project. So these are the API endpoints that was created for the project, and then what we updated the whole process. So after we were able to upload everything on our we were able to do the whole configuration of the Lambda function and API gateway. So that was when we checked our site because of we had a domain for it already. So when we checked the browser using our domain we pasted on the browser, so it showed that our web the application is fully hosted and is active. So in our application, we're able to place orders. This is a picture of the application where it is fully hosted and active. So we're able to place orders and then also connect the back end, and it was all working perfectly fine.
All right. All right. All right. All right. All right. All right. Are you guys done? Yeah,
Um,
the time is already up. So I don't think there's any reason to dwell on this. Is there any other very important thing to show? No. Okay. So well done, Team G. Well done. Well done. I would have had comments, but as soon as I'm able to see that you guys were able to get to the root of your application, you should have just shown a screenshot of how you were able to place order and how it interacted with the database, because that is what this shows the an interaction of the front and the back end. But the database stores the orders, it stores user information and all those good stuff. So if you showed it, it would have completed your whole implementation. I don't know if you still have that to show. But if not, you guys did very good work. very good work working on this and putting it together. However, in your next project, I love the documentation. Also, just add in more pictures, more and more explanations. For instance, can you scroll up a bit? Yeah, everything here is just like showing commands. This is what you did. Not there is nothing detailed about what each process does. So, for instance, you want to create a lambda, you put in some details about why you are creating a lambda. I don't know if you get it. So it shows that, how would I put it? It shows that this work, it is your process. It is a process that was done by a human. Because trust me, it's with the way the documentation is, anyone can get it online. Something like it is possible that somebody can get something like this online. But if the documentation carries is a bit more, a bit closer to the actual process that you used, you'd have more content. Don't get scared that it will run into 100 pages. It is your work at the end of the day. Just put in everything that is necessary regarding every level or every action or every configuration you make. But this is good work on its own. I appreciate each and every member of the team that contributed to this. Kosi, thank you so much for leading the team well. Great, thank you. Chisom, thank you. Yusuf, thank you. Well done for the work. I don't know if I hope I didn't miss out on anybody's name. So you guys did good work, and um, there will be opportunities for improvements. So just take the feedback and work on the documentations better, so you can be able to have a better documentation. So I don't know how I can give me the access to the documentation and access in a way that I can take the picture, like that picture that is there. I need to give me an access in a way that I can also like copy the picture and paste it on Notion. And somehow please drop the link for everybody on that channel so they
Okay,
can start filling it now. This should
okay,
be
I'll do that.
you guys drop everything, put in everything. So Queen Kosi and Grace just left. So discuss with Grace and Steve. You guys tell me if you guys can do this work on your own. If Yusuf, you're asking something. Yes, it is being recorded. I should have even stopped recording. God.